Hello everybody, it is 1 o'clock on Monday, April 14th, and you get a very special blog with me today. The reason why I'm blogging today is because you raised quite a bit of money on Sunday, and as part of the deal, I said I would blog. So we're going to get started by warming up the mill. And in 20 minutes, we'll do something.
It's so quiet.
What do you mean it's quiet?
It's so quiet. Like, it's turning, it's doing stuff. It's just I'm used to this thing like roar, and it's so quiet. So you're blogging
there's no
today?
tool in there.
You gonna tell them why you get a blog?
I told
you?
them.
Oh, okay.
You were talking. You didn't notice.
I'm doing important stuff.
I was doing important stuff. I was talking to the internet.
Hi, internet. I'm gonna go get my blog kit.
Okay. So the P number is dwell, and that works off seconds, so you can see what it does there. And it just increments up until it gets to basically the full speed of the spindle, and then it's warm. And what I'm going to be doing with it is these pieces of wood. If you look closely, they have a sheen to them. I have already spray painted them with a clear coat, and I did that so that when I go in and engrave it later, the colors won't bleed off in. This is a white pine, and it's not the greatest wood if you want to paint it, but it's a really lightweight wood, it's a really pale wood, and it's a really inexpensive wood, which is great because I am making samples today for a wholesale order, and if I get the bid, I'm going to have to make a lot of these. If I don't get the bid, it's okay, I tried. But it's not something where I can use expensive wood for because we're going to need to make quite a few of them. So the machine has warmed up. See, it's done. The light is green. That's the machine's way of saying, I'm ready. And now I have to actually go through the process of getting the program into the machine ready. I made my program. That part was pretty simple, and I'm not going to show it to you. Put my USB drive in, and then from there, go up. It's the only one on there. F2, copy to memory, overwrite. I always use the same program number on my stuff, that way I just overwrite it as I go. Otherwise I would end up having way too many programs on the mill, and you can really trip up the memory that way, so it's just good practice if you don't ever need to retrieve what you were using before. And I usually do one-offs or short runs, so it doesn't matter. It loaded. So now I have to do the rest of it because I can't just throw the part in the machine. I need to put my tool into the machine. So we're going to find a tool holder. It looks like it'll work. I'm going to take this one. And then I'm going to get my wrench.
What are you doing?
I'm getting the tool ready. Which is
a big strong man to help you there?
No, but it's just kind of a pain to do with one hand, so I'm going to stop. So I got that out. You didn't get to watch that part, sorry. And the collet that I was using is just a little bit too big. So we're going to swap this out.
And then it did the exact same thing again. It flies without any tail rotor, like the tail rotor's dead. So I replaced the tail rotor, and it still did the exact same thing. So I replaced the circuit board, the brain,
Oh, and I need my tool, otherwise I have to guess which one fits. Tool.
Hey, come here a second. I gotta swap ball mates real quick.
Very technical way to see which one fits.
This is ball mate pliers. Because this got bent in a crash and it ended up
And
like that.
none of those are quite right, but hey, that one is.
So, because it's such a complicated, you put the little webbing in it, because it's such a complicated, expensive.
So I saw we had this guy. We'll just use that. So we're gonna put this in there. See if I can do this with one hand. Ta-da! And we'll bring this over here. Oh, I can't use that one without a tool post, so put a tool post in. One thing at a time. So I'm going to tighten that, and I'm going to put the tool post in, which is just this in there. Unless I can find another one that uses the same size collet, and I'll just use that. So I'm going to get that set up, and then I'll show you how we do the next step. Okay, so I fought with it a little bit, and then now it's ready to go, which means we're going to put it into the machine. And that's something that I definitely cannot do with one hand. So I'm going to walk you through it, and then I'm going to do it. It's going to go in here, like that, and you get there by pushing this button. So just trust me a second. That was the sound of it going in. Now we're going to go in here, and we're using tool number 10. So we're going to go to Memory, Edit, change that to T10, change that to H10. Now the T says use tool number 10, the H says use height offset number 10. The machine is set so that you have to have your T and your H numbers match. You can set the machine to have them not match, but you have to be really, really careful if you do that, because obviously you can break things quite easily in that instance. If they don't match on this machine, it will just error out at you and it won't let you do anything. So we got that ready. Push reset, so now that we're at the top of the program, now we need to use the probe so that we know how long that tool is. And this is kind of a cool system, but I need calipers to do that, and I just saw those. So the tool is over here. It doesn't really matter for this tool because it's pretty obvious, but if you have a giant tool or fixturing in your vise that could hit it, it's a good idea to make sure that you're not going to run into anything. So now it says, press the tool offset measure key to start. You can choose to probe your selected tool, or you can check all of your tools at once, or you can manually check the tool. Doing them all at once can be handy if you're setting up for a big job and you went and set up all of your tools and then you want to go and probe them. So 5% rapids and cycle start. Oh, we have to close the door. This counts. So it's going to come up and then it's going to go back down. This can be kind of scary because it does move fairly quickly, but it knows that it's doing a probe cycle, so it's not going to hurt itself. And as always, be near the E-stop just in case something does go sideways. So it did that. I now have my offset set and it's ready to go. I need to put the part in and then we'll probe part so that it knows where the tool is in relation to the part, because now all it knows is where the tool is in relation to the machine, which doesn't do me a whole lot of good when it comes to my part. Okay, so I messed around with the vise a little bit, and I had to flip the jaws from the inside to the outside, and that's because my part was too big to fit in the jaws the other way. I didn't share that with you because I was busy doing it. Try as I might, I only have 2 hands. So we're cranking this down a lot. It's so much easier in this vise. Last vise, this process was a pain. Now, I paid consideration to how this piece of wood was aligned. I like that knot in the bottom corner. So we're getting right in there. I don't have a lot of engagement, you can kind of see, but I don't need a lot. I'm doing very gentle cuts. And I don't want to tighten it too much, because if I just tighten it with everything I have, I will break the wood. It doesn't take that much force. But by mounting it on the outside, you can see that it's pretty flatly supported, which is good. Now we're going to set our G54, which is home. Now I can use the probe to do that, but I'm not going to use the probe in this case because what I'm doing is not that particular. And so I'm just going to take my V-cutter and put it in the corner that I'm going to be using. Now I'm doing this in the northwest corner, which is pretty typical for a lot of the stuff I do because that's a corner that doesn't move a lot. So we're going to get the tool over, and then I'm going to set the offset, so you get to watch that part. To the corner. So now my part 0 has been set. I'm going to switch out to the probe tool. Now we want to do the probe in a place that's likely to be a reliable example of our height. And if you were doing this in metals, you would probably just surface it, so it would kind of fluctuate. So we just aim for the middle. I mean, even if I surfaced it, it would still fluctuate a little bit as we cut. So you just have to work with what you can. So now it knows where the northwest corner is, it knows where the top of the wood is, and it knows where the bottom of the tool is. This means we can cut something. Before we cut something, we simulate. The dotted lines are rapid movements, the little X's are vertical movements, and the straight lines are where it's actually cutting. On this particular program, it doesn't take that much time for us to simulate. On a lot of the more in-depth programs that I run, it can take ages and ages to simulate. It's still worth it to simulate before you cut, especially if you're going to encounter any situation where you could possibly cut the fixturing, the table, go off of your material and spoil the part, or snap your tool. It finished. It says this is good to go. I'm slowing down the rapid until we get going, just to make sure everything's okay. And we'll see it when it's done. So my piece cut. It was pretty boring to watch, but here we go. Now, it didn't come out quite as I had hoped it would. I don't know how well you can see this, but that's a flat bottom. And that's when I went and looked at this more closely and realized that it has a flat bottom. And that's not what I want. So we're going to cut the exact same program again, but I'm going to find a different tool, one that has a sharp bottom on it instead of a flat bottom. I think I might have something. I usually use these really awesome tools by Hair Saf with little inserts in them. But the problem is that Hair Saf has gone out of business because the patriarch of the family passed away recently, and they decided that they're not going to continue making tools, which is very sad. And I can't plan a wholesale run on something where I'm not going to have that tool available. If I was just going to make one or two, it's not a big deal. But since I need to make many of them, it is a big deal, and it won't work for my needs, because I don't have any more of those inserts. So this is pointy, and we will give this a shot. It's not quite the right tool, but it should work. It's the same angle, so we'll give it a shot. And I'm just going to swap out the tool. I put in a new part. It's the same size, it's in the same place, it's the same thickness. And since I'm not cutting anything terribly big, it doesn't matter that I have a slightly different size. They're both 90 degrees, that's what counts. So let's see what happens. Check it out, you can see through the window now, which is pretty cool. I just finished cleaning it. I also put in the new tool, and we're going to cut and see if this works out any better. So, rapid's at 5%. I'm going to crank the spindle up pretty high, and I'm going to jack down my feed rate because I felt that that was cutting just a little bit too fast. Usually on the sheet router, I'll put the spindle at like 24,000 RPM, which is the maximum. Sometimes I'll go to 20. And then you can cut at 100 to 250 inches per minute, depending on what you're doing. Pine and other softwoods require a different touch than most of the woods that we work with, and doing it on the mill is a little fussier, but I'm still troubleshooting, so it's not really worth it for me to go through the sheet router every single time. It's easier to just put it in the mill, put in a new piece, try it, put in a new piece, but if you get the ratio right, it'll scale up just fine. And as you can see, I still have the rapid set pretty slow. And this is not cutting. which means that this piece of wood is ever so slightly a different thickness than the first piece of wood, which is fine. What we'll do is go T25. Bring the probe up.
Hey, you cleaned the windows.
I did.
That's cool. I gotta go down to downtown Rosa Park Circle. I gotta do the stage test thing.
Wear a coat.
Oh.
So we're just gonna bring the probe out. You get the probe pretty close. And you do have to be careful when you do this, because if you're not paying attention, you can just slam into it. So there we go. Go into our work offset. So we're doing single surface. Press cycle start. You can see it beeps when it touches.
Paid $120 for that.
Alright, so now we're going to try again. The nice thing is because it does have the tool pinned in it, I don't have to go through the process of getting the tool back. You can just let it do it. Now we're cutting. So I'm going to put the rapids back to 100%. But I'm cutting pretty slow. We're cutting at 8,000 RPM and 20 inches per minute. It has an approach of 9 inches per minute. I can probably speed that up a little bit. But that ratio is about perfect. So I'm just going to be a little conservative with that and let it cut, and we'll see what it's like when it's done. It'll probably be a good 15 minutes, but if you consider that the final product will be run on the sheet router, the whole thing will take 2 or 3 minutes. So it's worth the wait for the prototype. In the meantime, I'm going to get some stuff set up with the Affinia machines. So I was walking over to my workstation to work on the Affinia machines when I noticed Mike is working with a new member. What are you guys working on?
We're trying to make the text fit on this box.
It's way too big right now.
Yeah.
Oh, you can just grab the corners?
No, we couldn't find the corner.
Oh.
Corner's outside of the
Looks
screen.
like you found them.
Yeah.
So it's a little bit small. We'll start here.
I would center that and then stretch it.
When we did the text, like this right here.
Oh, I had
Well,
some. Yeah, okay.
well, if you close the text box,
Right here, close.
close, if you hit align objects, then it'll be in the center. And then what you can do is, if you click on it and hold shift down, it will center it by it'll make it bigger and maintain its location. So click on it, hold shift. Okay, you have to be in the right arrow. Get in the arrow so that you can make it bigger.
Oh, you don't have it.
There you go. Now hold shift down as you grab the edges of the square. There. And then you can see how close you are to the edge of your box, and you don't have to move it around each time.
In his, he has it centered in the middle.
So then you go into the text and you hit the text tool. Yep, it's highlighted. So hit the text tool.
Is that this one?
Yep. And then just choose center and then hit apply. And then you'll have to recenter the object, but just
hit close there.
Just try that again and it should work. He's making some signs and he found some pieces of cedar to do that with, so that's pretty cool. And I'm going to open up 3ds Max, which is my very favorite piece of software. Quite possibly my favorite piece of software I have ever used. 3ds Max. Which is one of our newer pieces of software that we get to use in the shop thanks to the power of the Autodesk. And I don't know if I've told this story before, but I got into CNC kind of a backwards way. When we got the machines, I was very familiar with how to model things on a computer and not very familiar with machining. And the software that I knew how to use to model things was 3ds Max. So from the very first day in the machine shop, I knew how to use 3ds Max to make something to turn into a model that you turn into dual pass. And 7 or 8 years ago when I started, that was a completely backwards way of thinking. Nobody did that. It was considered very, very strange. And since then we've gotten things like SolidWorks come out, and people are used to working in a more 3D environment where you're not necessarily working strictly in AutoCAD. And I've always liked 3ds Max better than AutoCAD. It just fits my personal way of thinking and my personal workflow. I like working in 3ds Max. And it still gets me a lot of funny looks when we get machining companies come through and they're like, so what do you use when you want to make a model? Or 3ds Max. And I, well, how do you do that? And it's just the way that I think, and I like it. So, fresh slate. I will be back in a few minutes with what I have made, and then I'll walk you through how we're going to take what I drew and print it on the Affinia machines. So the part's done. It took 13 minutes and 58 seconds, which is right on par with what I was guessing it would take. And this looks so much better. So much better. Check out the quality of that cut. Nothing quite like overkill, like Haas overkill and adhesive. So I'm going to take this and get that set up for colors as soon as I finish working with the Affinia thing, which is almost done, and it looks pretty cool. Let me show you what I'm doing with that. Over here. Hey Mike, I'm done on the mill, so you can use it. Let's check this out.
And so let's go see how the board.
This is the front view, the left view, and the ISO view. I like it. I was kind of playing with the angles a little bit. I wanted something kind of interesting looking, and I'm going to run it through the simulation, and then I'll walk you through running it through the simulation. So I imported it into the Affinia software. See, Affinia. And that's what it looks like, which is pretty cool. When you hit place, that sticks it on the bottom, and we're looking around, and everything is pink, which is cool. If there was red, that would mean that I had something funny with my model, but my model is good. So now from here, I need to go get the 3D printer set up. We're going to do it as a time-lapse video, so instead of just going down to rapid prototyping and plugging it in, which is what you would usually do, I'm going into AV, going to make sure that I have the computer for it, and get the 3D printer up on the autopsy set. That's where we decided that we're going to be shooting this time-lapse. And then we'll get going. We're going to put up an AV because I need to make sure that the light doesn't change, because we did a time-lapse before and it looked kind of weird because the light kept changing down there because we have windows. And I want this to look nice. So we're going to get this set up in here. And apparently I need to find a computer. So I'll get that and I'll be back. Okay, now we are in Studio C with the 3D printer and my workstation. So I have the Affinia software open, and we're going to open up my file. Which looks pretty familiar since we were just looking at it. And we're going to go to Place, which did nothing because I made the file the right way the first time. Go me. Now we're going to go up to 3D Print and go to Maintenance and get the table heating and hit Extrude. You heard it beep. That means that it's now warming up the nozzle and the table. Now you can see on the table I have my work surface clipped in. Very, very scientific binder clips at work here. Now at this point you really don't want to touch the machine because, as you can see, caution, hot. And they mean it, because right now The platform is at 32 degrees Celsius and the nozzle is at 92 degrees Celsius. I would rather not touch that. I'm sure you don't want to either. While it is heating things up, we can do the preview process. Oh.
Oh no, he's just talking to me, sorry.
And we will go to print preview. Prepared for printing layer. So it's going to think a little bit. There we go. And now it will tell us how long it's going to take to print this. We have 781 layers, which is kind of a lot, but as you can see, some of the layers, there's not a lot of content to them. I don't know, I might have been able to make this shorter. I'll see how long it'll take. I may come back. We'll see. It's thinking.
I think it'll be okay now because I can actually read the caution hot now. It was just blowing out before.
So,
On the white.
we'll warm up and then we'll walk you through the rest. So I made it smaller because I didn't gain anything from the extra height and I just didn't like how it looked. So now we're at 219 layers and it's doing the print preview. I also went in and checked the resolution and the fill and everything, which I'll walk you through as soon as it's done doing the print preview because I can't open that up while it's thinking about something else. But that can make the difference between a 3D print that takes an hour and a half or a 3D print that takes 27 hours. And maybe for what you're doing, you absolutely need to have rigidity, but maybe you don't. This is going to use 121.9 grams of material, take 3 hours and 54 minutes, which is totally fine. So we're going to hit OK, and then what we're going to do is come up here and go to Setup. So that's where I picked my resolution, and the fill, I picked a big hole. My support structure is very broad, but I don't think I'm going to be using any support structure here at all, because as you can kind of see, this lends itself to not needing support structure, which was more or less the idea. Now, if we go back to maintenance, you can see the temperature and the nozzle extruded. We have quite a bit of fuzz. If I wanted to swap out the color, I could, but I rather like the red in this one, so we're just going to keep it.
You'll lose a lot of options, but not at stop.
What?
I am ready whenever you are ready.
Alright, 1 second.
That's fine. You can see it's thinking. The light is blinking.
The only thing is on this camera and also but
I think it goes to 10, it goes to 8, and then 15.
So we're going to go ahead and hit print because it has to think through that whole print preview process that we just did. So we might as well let it do that. It will ask you to confirm before you start 3D printing. That way you can make sure that you're all set, everything's ready to go. If your printer is not completely up to temperature before you start, when you hit print, it will warm it up and then start. So if you don't do the warm-up process while you're messing around with your model, you can spend a lot of time waiting. It's good practice to just do that when you start. That way everything's warm and ready to go. The really nice thing is the Affinia, when you heat the table, it has a heat for 1 hour function, which means it'll heat the table for up to an hour. If at the end of the hour you're not printing, it will stop heating it. If you are printing, it will keep the table warm. So if you get busy and walk away from it, you don't have to worry about the table getting too hot. So now it says, system ready. Please set, oh, I forgot to initialize it because we restarted it. And then we will get set. So it just beeped at me and let me know that it's ready to go. Click OK. And I'm not going to get too close up in here because we're shooting time lapse. So while I was up working with the 3D printer, they got some stuff cutting down here. That looks like it's making a pretty good cut.
Is it going to take another pass?
If it's finished with the letter, it won't take another pass.
Okay.
It goes to full depth and then moves on to the next one, usually.
Okay. So he was thinking it should go a little deeper, but I thought maybe because you put the max 125
No, the 125 was the first step.
per step.
So it's going the deepest that it can with the mouth of the V cutter.
Okay.
So if you went further, you would go further than the width of the letters was expecting you to go.
All right. Now, if I wanted to have that, the letters a little...
So it is working on it. You can see. As I said, I'm not going to get too close, but it's just doing the very beginning. So we will come back in a little bit. Can I get up here? What it's doing right now is setting the infrastructure support to the bottom. And this is a good example of what that kind of looks like, though mine's much broader. This was a fairly high resolution one. And we do that so that you don't print straight onto the material. You want some support structure. Makes a more stable part when you're done. If you were to just print the letters straight onto the board, they wouldn't be sticking to plastic, they'd just be sticking to the board. And that's a silly point to have a failure happen, and it's really easy to prevent. You make just some support structure that covers the whole area that you're going to be printing. So that says it has 4 hours to go. It's 4:30. I'm not sure that I'm going to show you it by the time it's done tonight because that's kind of late. But the nice thing about the 3D printers is you really don't have to sit and monitor them. You can really just push print and go. I mean, it's a good idea to be somewhat near it if it starts to fail and you get a big goopy blob of plastic. But I don't personally have to be there because there's lots of people in the building. And they can monitor it on the live stream, which is kind of cool. So that's done. I don't need to monitor that. They're cutting still. And that's going good. So that means that I can take my part that I was working on earlier. Not that one. Hey Mike, where did my other part go? Did you take it out?
I didn't touch it. It was it.
It's not that one.
It's not?
No, I had another one.
Did we take the part out?
I don't remember taking the part out. Maybe I did. Find my part. Found it.
Oh.
I'm going to take this and we're going to paint it. So now I have to play find paint. And it's not spray paint. You don't want to spray paint this. It's special paint, so I'm going to find a special paint. It's now 5:15. And once again, staying out of the way. You can see it's doing stuff. So we're almost out of the support layer, and I added about a 1/4 inch of support base into it. That way it would stick to something instead of just be floating in space after we remove the support structure. So pretty soon it'll start looking like something, but so far it's printing perfectly. Over here, this came out great. It is drying. And since it came out good, I'm going to get the next piece up and running. Jim finished cutting his stuff, so he doesn't need to use that any longer. It does mean I have to completely reset up my offsets, but that is not a big deal at all. So I'll get that in there, and I made 3 designs that are very similar, and I'm going to cut the other 2. Have some feet and speeds that were working good. We'll see what it looks like. Now we're cutting the second one. And in a few minutes I'll have that. In the meantime, I think my first piece is probably pretty dry. Yep, so I will go grab the sander and we will clean this up. aggressive than that. Cool.
Feel like shit, bro. That didn't get too far down.
Dust it off. Much better. It still bled a little, but this is just kind of a test run. So that's okay. And you can't really tell visually, but after I sanded it with the 220, I sanded it with 600, so it's very smooth. And I kind of like the rough edges around it, but that's kind of my woodworking aesthetic. I like rough edges. Now I'm going to find some of the clear coat and we'll put a finish on this and have a final product. I still have to put a notch in the back, but I can do that with all three once I'm done, if I can find my lacquer. This is the best. I love this stuff. And it is, of course, the Rust-Oleum product. So I would like to mention that I decided that it was the best regardless of who made it. I have tried all kinds of lacquers. The woodworking world has no shortage of them. And most of them I really don't like. I don't like a lot of the more traditional woodworking finishes. I think that the finish aspect of it should make your product look better and should not take a lot of effort. And usually it takes a lot of effort and you don't get that much of a difference. So this does a really good job, and all you have to do is spray it on. See how hard that was? We'll let it dry, and I'll probably do 2 more coats if you look close. I don't know if the light catches it, but since this is pine, there's some fairly large grain in there, and the thicker parts of it absorb at different rates, so you get kind of an uneven finish. But after a couple of coats, it's all glossy. Well, not super glossy, this is kind of a middle road finish. And check up on this. Looking pretty good. This looks different than the other ones because it's a slightly different part of the wood. That's something that I like about working with wood stuff and the part of it is everything turns out a little bit different. Even if you run the exact same programming pieces of wood that are the same size. I think that's neat. At the moment, I just need to wait. So it has cuts. Let's check it out. Awesome. It's a little thick, this piece of wood bowed a little bit in the middle, but it's fine because what I'll do is I'll just sand it down and it'll come out okay. My main thing is this is a prototype. I have to make sure that the design works, and we proved on the first one that it works great. And this looks pretty cool too. is now almost 9 o'clock and I came back to the lab because I'm doing an AMA tonight. You're not going to see that on the blog. If you want to see that, you have to watch the Justin TV archive. But I'm getting set up for it. It should be pretty cool. I was requested for the AMA, so that's what I'm going to go do. We're doing that up in master control. The Affinia is still plugging away, so I'm going to work on that again tomorrow. And I will probably show that to you, although I don't think I'll be doing the blog. You guys didn't raise as much as you were aiming for to have 2 of them, so you just get 1 blog from me, and that's the end of my day. Okay, so it's 10 o'clock, and turns out they met the fundraising goal, so I will actually be doing a little bit of blog tomorrow because that's what you wanted. And if that's what we have to do for the internet, then I will blog a little bit for you tomorrow and try to actually accomplish things. And then we're doing an AMA with editor on Wednesday because you met the goal. So good job, everybody, and I will see you tomorrow.